First, thank you for the Petroleum Summit this March 25, 26 for inviting me as your speaker for this uh, prestigious event. And as Magellan discovered the Philippines over 300 years ago, it's on March 17, 1521, and you have discovered me also here in the Philippines and as well as in Barcelona, Spain. And I want to thank John Dixon, special thank to to John Dixon for allowing me to be part of this event. Thank you very much. And allow me to present my uh, my uh, my study entitled Potential of the Solar Sharing Smart Lighting Artificial Intelligence Platform for Hal Biocraps on the Lactuca sativa or the lettuce on the indoor hydroponic systems. So I'm Dr. Myrtel S. Bernardo from Philippines. So first, a study is on the concept of the sustainable development goals set by the UN. Okay, then we have the no poverty, number two, zero hunger, good health and well-being, climate action, and life on land. And this study has this concept of having the smart lighting systems more economical using the Arduino and to be a power efficient using the renewable energy like the solar power. And this will lead us to our food security. And this study investigate the effects of AI treatments on the growing performance in terms of weekly plant height under varying control. So we have the control systems using the fuzzy logic as the technical contributions. So I have three treatments: the smart lighting with the manual setting, and a smart lighting with the IoT technology. Okay, first we have to explain what is hydroponics. Hydroponics is a form of gardening which doesn't use soil at all. Instead, it uses the mix of minerals or nutrient solution and water. And that end, it has an advantage of faster plant growth, double the yield, space efficient, save more water, free from pests and lighter gardener tasks. And it also has the indoor farming. So as we can say, the indoor farming is more of the alternative way of planting our vegetables. So we can grow it indoor. So it can be an alternative food and nutrition supply to densely populated cities and contribute to address the impending food insecurity. That also reduces the chemicals, pesticide use, and a climate control environment for all year round and more reliable food production. This also took into automation of growing light using the artificial intelligence and control systems that automatically adjust the light requirements needed by the crop and using the solar sharing technology. And it uses also the Internet of Things, big data, the artificial intelligence to extend or to speed up and increase the efficiency that affects the entire production chain. Okay, the objective of the study is to evaluate and the yield performance of the lettuce in terms of the different AI treatments applied on it. And it also determined the significance difference of the LED treatments and conduct of economical analysis of the system. The methodology, it starts with the experimental design using the smart LED lighting based on the policy logic application and deploy it in the hydroponics and the solar power or the solar sharing energy apply on the lettuce. Then we come up with the setup with the Arduino, the MOSFET, the module motor, the precision real-time, the light sensors, and LED that's set up and applied to our lettuce accordingly. Then we have the data gathering, daily monitoring of the plant growth as observed, and the illuminance performance of the smart lighting system. And the data analysis is collected between 36 or up to 36 to 40 days of lettuce. It can be harvested and weighed it and subjected for the proximate analysis or nutritional analysis in the laboratory to test if there's an effect of the LED in terms of its nutritional value. Okay? And as you can see, we have the input, the process, and the output. So the inputs are in the farm materials, the LED lightings, the exhaust fans, the controllers, microcontrollers. Then the process is on the monitoring of the temperature, the carbon dioxide, the water, and the power requirement. Also the growth monitoring, harvesting of lettuce, and comparing the yield in each different LED treatments. And the output would be a smart lighting system with a solar sharing and a monitor or the monitored or the data collected within the planting procedures, the growth performance of the lettuce, the yield, and comparison of its different treatments. So as you can see in the diagram, there's a lot of boxes that it's the black diagram of its control system. Okay. So we use the RGB LED light or the red, green, blue light emitting diode. We have also the RF50, which is the MOSFET that switching and off the power. We have 12 volts of volt power supply. And we have the node for open source, which is the data transfer to the Wi-Fi. And the voltage adjuster. We have the LDR or the module that is used to measure the light intensity, which is from the window near the sunlight. Then we have also the nano as its microcontroller, then potentiometer, and the liquid crystal display. Okay, then we use the Blink app as the platform for leading the IoT project. So we can control the intensity of the light when we are far, or we can adjust it manually. And also we can monitor what illuminance or what DLI or PPFD is on that time. Okay. Okay, here's the actual setup. Then I put it on a small room in our school. Basically, it's in this project ran to after pandemic, because after pandemic, there's a lot of food insecurity that we're not able to buy a lettuce, and the price of the lettuce is very high. Okay. And there's a computer that monitors the growth performance of the lettuce. And it is near the window so that there will be a sunlight on it, and the auto-adjust control system. If there's a sunlight, there will be no light on the smart lighting system that it can adapt. But if the intensity is low or dim or somewhat cloudy, then the system or the smart lighting system will detect that the illuminance coming out from the sun or from the window needs to be filled up by the smart lighting system. Okay. And through the evaluation of the system, so we have the illuminance performance, the growth monitoring, the height and the weight. We have conducted the sensory evaluation, nutrient analysis through laboratory testing, which is they called it, the food technologists call it the proximate analysis, then a statistical analysis, cost analysis, and return of investment, or the ROI of the project. And as the resulting discussion, okay, the illuminance performance, as I stated last time, if there's a low intensity of light, which is ranges from 0 to 150 ppm, the output of the smart lighting system would be on a high intensity. If the sensor sense that there is no light at all on the window, or the sensor doesn't sense any light on it, the smart lighting system will now cover or will automatically adjust on the needed intensity of the plant. Okay, then there is a moderate intensity, which is 500, 151 to 300 ppm, and the high intensity is about 301 to 400 ppm. Then why is it that 0 to 455? Because lettuce uses that range. Lettuce is more on the lower intensity needed lights. Okay. Okay, as the growth performance and the yield performance of the lettuce with the different treatment. So the treatment A, so it shows a progressive, as in the what we say, the line 1 to line 9. So I vertically adjust this. It's set up into 9 layers. So kaya there is a layer 1 up to layer 9. Okay? And treatment B, like smart lighting with the manual controller, also has its linear or progressive bar, as well as the treatment C that has the standard deviation of 6.9 with the growth performance, which is the best treatment at all. Okay, at all AI treatments. Okay, as you can see there, I also have the control. The control has no lighting system at all. So alone, no other smart lighting support on it. It's alone on, or it is separated from the setup I used to be. Then after 36 days of growing the lettuce, I weigh in the per grams, and I make the difference of that control to treatment A, B, and C. As you can see, that treatment C with the lighting support on the AI technology, or the IoT technology, has the highest yield and the weight among all treatments. Okay, in the sensory evaluation, that the attributes according to its color, crunchiness, bitterness of the stem, and as well as the bitterness of this leaf, the treatment C colors was extremely green and extremely crunchy. The treatment B tastes moderately bitter, and the leaves of the control. That implies that treatment C and A has a bland taste acceptable to the panelists, and the treatment B and A has no significant difference in the crunchiness with respect to treatment C. And the laboratory result, which is the approximate analysis with the parameters of its moisture, ash, fat, and protein. So the table shows that there is no significant difference of the lettuce grown indoor with a smart lighting system on it and the naturally grown in the Philippines. So it is safe to eat the lettuce grown using the smart lighting system. Okay, the cost analysis and return of investment. So it is an all year round and no pest at all, no application of pest control, pesticide, insecticide, because it is an hydroponics, so it is free from that pest. And the ROI is about 54.772%. So it is more, it's has a great ROI. And we have also the DLI and the PPDF result. So it is more on the DLI or the daily light integral of the lettuce needed and with the photo period compared to its smart lighting system. So as you can see in the around 5 p.m. to 4 p.m. 24/7 the monitoring without a a smart lighting support on it, there is an even distribution of the DLI. And when we put on our smart lighting system, there's an equal distribution of the DLI. Okay? And as a conclusion, so treatment C or the solar sharing smart lighting system fully automated with the Internet of Things has the highest yield in terms of height of 25 millimeters and weight of 350 grams and product. And the standard deviation is 6.009, which means that there is a significant difference between the treatment and the terms in varying light conditions. And the sensory evaluation that treatment C is highly satisfies the criteria and attribute that makes it highly acceptable. The laboratory testing of the proximate analysis confirms that there is no significant difference of the lettuce grown indoor in a smart lighting system and the naturally grown. The cost analysis also in investment is approximately 10,800 pesos or approximately 193 US dollars, which approximately 3 kilograms of lettuce per harvest. And the ROI is 54.72%, 77.2%. The DLI and the FFF illuminance of the smart lighting system is or was accepted. It is cost-efficient way of growing lettuce indoor in vertical farming, and the solar energy from out or near the window is good source of renewable energy that lessen the cost of consumption of electricity by 75%. That's uses. So in that end, there are a lot of recommendations. We have to put in the temperature and the humidity as well as the nutrient management as well as the microbial analysis and shelf life of the lettuce. So with that, I have the published article on my study. You can visit that and read my articles about this solar sharing smart lighting artificial intelligence for the high value crops in the indoor hydroponic system. So thank you very much and thank you for listening on my project or my